All right, so I'm going to go over a few problems here that people had questions on and posted in the comments in Classroom that they'd like to go over these. So a couple off the review and then a couple off of 5.4. So this is number 18 off the 5.3, 5.4 review. And 17 and 18 are both asking us to find the exact values of sine, cosine, tangent of double angles, given the well, in number 18's case, given the sine of x. So we're told that x is in quadrant 4, okay? But then the other thing I'm going to write here is that if angle x is in quadrant 4, then doubling that angle would put it somewhere. I'm going to just double all three of these pieces right here. Just double all three of those. So I get 2x in the middle then. 2x is greater than 3 pi and less than 4 pi. So we know that 2x is somewhere between 3 pi and 4 pi. In order to find these three double angles, we're going to need to know the sine of x, cosine of x, and then the tangent of x. I'm just going to write down here real quick the formula for each of these. Sine of 2x is equal to 2 sine of x cosine of x. Cosine of 2x, we could use any of them. I'm just going to use the same one that I used when I did my key, which is 1 minus 2 sine squared. And the only reason I think I picked that one is just because if this were the only thing I were finding, I wouldn't even have to do anything because I already have sine, so I could just use what I'm given right there. And then the last one, tangent double angle, tangent of 2x is going to equal, which one are we going to use here? 2 tan of x over 1 minus tangent squared. All right, so using those and using what we have here, sine of x, the first thing I want to do is find the cosine. So another cosine squared equals 1 minus sine squared. So we're going to have 1 minus 16 25ths. Negative 4/5 squared is going to be positive 16 25ths. And that's going to give us 9/5, or 9 25ths, excuse me. And then you're going to take the square root of that, because that's cosine squared. Therefore, cosine is 3/5. But we know it's in quadrant 4, so we got to think about that. Is cosine positive or negative in quadrant 4? Well, cosine's positive, so we're going to leave this as a positive value. So we have sine right here, and we have cosine right here of x. So I can find sine of 2x by taking 2 times the sine of x times the cosine of x. Well, I have both of those. That would be that negative 4/5 times the positive 3/5. So we're going to have a negative answer here because we have 2 times a negative times a positive. So we're going to have, let's see here, 12 times 3, 36 over 25 here. 12, oh no, I'm sorry, 12 times 2 is 24 over 25. All right, and so that is the sine of 2x. Let me just, I have no idea why I changed colors there. That is the sine of 2x is equal to negative 24 25ths. Okay. Makes sense that sine is negative because between 3 pi and 4 pi, see here, here's 1 pi, there's 2 pi, 3 pi would be right there. Between 3 pi and 4 pi would be this spot right there. So sine has to be negative there. All right, now let's find our cosine of 2x. And I'm just going to use 1 minus 2 sine squared. So 1 minus 2. All right, now remember using sine squared, which would be that negative 4/5. squared to give me that 16/25 again. So this is going to give us 1 minus 32/25. So we have -7/25. All right, now that just kind of locked down where exactly the angle 2x is. We know it must be, since cosine is negative, it must be somewhere actually here. That's cosine of 2x. All right, so these are the answers. I found cosine of 2x, and I found sine of 2x right now. Okay, so now, since sine was negative and oh man, cosine is negative. What am I doing here? It's a good thing I come back and check my work. Good thing you guys don't ever get tired of me making mistakes. Since cosine is negative, let's try that again. We knew sine was negative, but the fact that cosine is negative tells us we are actually in quadrant 3. This is where our double angle, our 2x, must be. That is a 3. World's thickest green marker. There we go. So that means that tangent is going to be positive. All right, so now tangent should be pretty easy to get here. We don't need to use, actually, I know I wrote this here, we don't really need to use that. What we can do is just take sine of 2x over cosine of 2x. So I'm going to just take that numerator over that numerator, which is going to give us that positive value anyways. So the tangent of 2x is going to equal positive 24 over 7, because I have a negative over negative, or also we said we must be in quadrant 3 here. You know, this first told us it's either in quadrant 3 or 4, but once we found our values, it ends up working itself out. The positive and negatives will tell us what quadrant it's in. And even if we didn't know, uh, we have, you know, this negative and this negative is going to end up giving us the positive tangent of 2x anyways. So the positives and negatives will work themselves out. So these are our 3 answers here to this problem. All right, so the next question that was asked about was number 35 on the review. This is actually a really quick one. If you notice the similarities between this left-hand side and the half angle formula, or excuse me, the double angle formula. I'm just going to write here what the double angle formula for sine is. We know sine of 2x equals 2 sine of u times the cosine of u. Okay, actually, let me put a u here so that we have all the same variables. Okay, so knowing that, whatever this is right here is what shows up right there and right there. Okay, well, if you look at what we have on this side here, let me just start by writing my left-hand side. Look at that pattern. It's not 2 times sine and cosine of the same value, it's 4 times that. So what we can do is change that 4 into 2 times the sine of x over 2 cosine of x over 2. What we have right here is the double angle formula for sine, okay, with our u value being x over 2. So I still have that 2 that's out in front, but now I can replace the rest of that with the sine of 2, and then our u value is x over 2. So I'll just put that in parentheses. Well, that can be simplified. These multiply together, 2 times something divided by 2, those 2's will cancel out, and we're simply left with 2 times the sine of x, which is the right-hand side of our identity. All right, so you have to recognize how much this looks like that side right there, except we're saying u is that x over 2. That's what's being repeated each time. So, you know, flipping this around, maybe it would have been better for me to write that this equals 2 sine of u right there. And what we're saying is u is x over 2. So then this thing, when we say that u is x over 2, that's what these guys were. So that's what this is. And that's what we replaced it with then. All right. This was wrong. Sine of 2u. Worst part about these is you can't, these videos, is Can't go back and rewind and fix mistakes. You guys have to notice that I make a mistake and then wait for me to fix it. Good thing you're patient. All right. So next one here in this video that was asked to be done. Well, let me look at my notes here. Number 48. A little bit longer one here. Actually, this one shouldn't be too bad. Oh, 48's not bad. It's the one in 5.4 that's a little bit longer. Okay, so we got to start by getting rid of this double angle. But we don't have a secant double angle, so we're going to change secant into 1 over cosine. Since it's secant of 2x, it's got to be cosine of 2x. This equals 2. So all we did was replace the secant of 2x with 1 over cosine of 2x. And then the cosine of 2x, let's see, let's get that actually out of the denominator first. So I'm going to multiply both sides by cosine of 2x and then divide by 2, or in other words, I'm going to flip those two guys right there. We've done that sort of thing before. Let's see, so 1/2 equals cosine of 2x. All right. And actually, to be honest with you, I don't really like having that 1/2 there. I am just going to instead multiply both sides by the cosine of 2x and not divide by the 2. Alright, so these cancel out, and we're just left with 1 equals 2 cosine of 2x. So I did a little bit less than what I was going to do originally. The reason why is because now I want to replace this with one of my double angles for cosine. And actually, I think 2 of them would make sense here. The one with only sine or the one with only cosine. I'm just going to stick with the one that is only cosine. So 2 cosine squared minus 1. Because you only want to have one trig function if possible. All right, I'm going to distribute that 2. Distribute the 2, so we're going to have 4 cosine squared minus 2. And then I'm going to get cosine squared by itself. I'm going to add 2 over to the other side, get 3/4, and or get 3, and then I'll divide by that 4 and get 3/4. So that's where we're at right now. I'm going to need to take the square root. So I'll just do that here and flip my equation around. Square root of 3 over 2. We took the square root, so don't forget positive, negative. And now we just need to use the correct reference angle in all 4 quadrants because of the positive, negative. All right, so what angle has a cosine value of square root of 3 over 2? Well, that is, I'm just going to use actually a reference angle here. Theta prime is going to be pi over 6 in all 4. All right, so we know we're going to have all 4 angles going around the unit circle. I just need to go back up and look at what my directions are. We are only looking for our answers on an interval, so I'll just list those 4 guys out. So we have pi over 6, 5 pi over 6 in the second quadrant, 7 pi over 6 in the third quadrant, and 11 pi over 6 in the fourth quadrant. So get rid of secant by using the reciprocal identity, and then get rid of that cosine of 2x using a double angle identity. All right, last one here is going to be on our 5.4a worksheet. This one right here on number 19. So we are verifying an identity here. We want to verify that the sine of 3x equals this right-hand side right there. That's going to be our final answer. So what we have here so far, I've kind of started already. I started by writing my left-hand side. Then I separated 3x into 2x plus x so that I could expand that out using my sine sum formula right there. And then, now this is not stuff that I would write if you were doing your own problem, but because I'm doing this as kind of an example, recognize that sine of 2x and cosine of 2x, what I have in purple and that bluish color there, those we need to replace. So, the purple one's easy. There's only one thing you can replace sine of 2x with. So actually I'm going to start writing that over again. We'd have 2 sine of x times the cosine of x, and that is being multiplied by the cosine of x yet. Okay, you don't need to put that into parentheses because it's all being multiplication there. And then that is being added to. Now the reason why I picked this guy out of the other two is basically what I have on the right hand side there. You know, it looks kind of like that. It's got the cosine squared minus 1, so I figured that would be the right thing to go with. So let's go ahead and replace that. 2 cosine squared minus 1, and then I got the sine of x right here. All right, now when you're doing these, sometimes you might take a step that you end up going back and undoing later. For example, you know, I don't know if I really should distribute this or if I should leave that sine of x outside of there. I'm gonna distribute it just in case um, if I can combine some like terms later. But I know right now, for sure, I can call this cosine squared. So that's what I'm going to do. I'm going to call this guy cosine squared right there. So we have 2 sine of x times cosine squared, and then plus, and then I'm going to distribute that sine of x. And the reason, again, that I'm doing that is because I think I'm going to be able to combine some like terms here. So I'm going to bring this guy in and call that 2. I'm going to put this in the same order as the one in front of it because there is for sure a like term that I can combine. 2 sine of x cosine squared, and then I also need to bring it to that minus 1, so it will be minus 1 then. And then I have to combine these guys here. That guy and that guy like terms. We have 4 cosine squared, the 4 sine of x, cosine squared, and then we also have the uh, oop, there's one of those patented Olsen mistakes again. That should be sine of x, and the whole reason I caught that is by looking up at my right hand side. I know I need to pull out a sine at the end. With that minus 1, I couldn't, so I must have done something wrong. Yep, there it was. So there's our minus sine of x, and now I can pull that sine of x out as a GCF, which would leave me with 4 cosine squared minus 1, which is our right hand side, and all is right with the world. Like I said, you know, these are really things that you wouldn't write if you were doing this problem on the quiz or in your homework. Okay, all this goofy notations that I have. I just do that to help us follow along as we're going here. But there is that proof.